Okay, so next class 9, video 4, exercise 13.5, these questions, okay, A, 1, 2, 3, 4. There will be no test for these, okay. So let us start it. Question A1. You find this on textbook page 244. If the volume of a cube is 3 root 3 a cube, then the surface area of the cube is, you have to find out. So let us say this is the cube. Okay, then the h is unknown, let us say, so it is a. So right here, let a be the h of this cube or the cube, whatever you like to put, h of the cube. Okay. Now, since question clearly mentions in the first sentence that its volume is, okay, its volume is 3 root 3 a cube. Please notice that. Therefore, in other words, that means there is volume of a cube formula that we know. At the beginning of the chapter, we dealt with the volume of a cube is a cube, and we put a capital because that's what we decided to put as the h for. Is means equal, then this is the value 3 root 3 a square, a cube, sorry. Then we know that if you remove the cube on one side, then cube root will come on the other side. Now when you write the cube root, better remember this, that the cube has to go inside the curve, otherwise it will become square root. Okay, if you write like this is wrong. This is 3 into square root. So since you are removing cube, the cube should go inside the curve. Okay, so here, keep that in mind. Okay, so here, this will be here 3 root 3 a cube. Next here, cube root over. Now let us deal with this area. Now we know this 3 here can be written also as root 3 into root 3. We know this. Root 3 into root 3 is 3. So this 3 can be replaced by this here, root 3 into root 3. So that it will combine with this root 3 which is already there, a cube. Make sure that root sign cover everything. So why did we do that? So that we'll have a triplet of the same root, 3 root 3. So we can remove it out of the cube root, and so single cube root 3, single root square root 3 will come out, the cube root, and then a cube triplet will come out as single. So that is the value of a. Now the question is saying surface area, so you just write here. Therefore, its surface area, formula for surface area of a cube is, we know 6a square. So we write that one. 6, then a, just now we got here, see root 3a. So just write there, root 3a, and we must put bracket, otherwise it will be wrong because there are two factors here, and this square belongs to both, right? So here, now let me show this one. 6 into 2 into 3 whole square is different. This is equal to 6 into 6 square, so that is like that. Not 6 6 is 36. 36 into 6, like that it will go. So 36 into 6, 18, 19, 216 is the answer. But suppose you didn't put bracket, then it will go wrong now. So here, see here, 6 into no bracket, then you will be writing like this, 2 into 3 square. That is totally different. 6 2s are 12, and then 3 3s are 9. So 9 2s are 18, 9 1s are 9, 108 and 216. See, they are totally different. That's why the bracket is a must there. Okay, so now here, once you're through with that, 6 into root 3 square is no more root will be there, and a to the power 2 is a square. So 18, 6 3s are 18, a square. Now the only answer, this is a multiple choice question, so go to your text, and the answer that matched that is C. So answer is C, which has the same value, 18a square. Okay, so that is A1. Let's go to A2, and A2 is, let me read the question for us here. The diagonal of a cube is 16 root 3 centimeter. You have to find the volume. So let us draw the cube again. So here there is a cube, and we know cube means the length, breadth, and height are same. So let us say A is the h, and there is a diagonal, means the longest line or stick that can go inside. So the length of this diagonal has been given. Question is saying the stick or the line is 16√3 centimeter long. We have to find the volume with this information. So let us write down. So right here, let A be the edge of the cube, or you can also say the given cube, whatever. Then, since question has given us, since its diagonal, very clearly its diagonal is, okay, let's just write one sentence form. Its diagonal is 16√3 centimeter, according to the information of the text. That is, we can apply the formula for diagonal of a cube. In the beginning of the chapter we did, right? So we know that it's √3 into h, and h we have decided to put a. Each means equal, and the value is already given, 16√3 centimeter. And this √3 will cancel this, because if you shift, it will go to the denominator and cancel that, right? So that gives you a equal to 16 centimeters. So the edge of this cube is 16 centimeter. So if you have found the edge, it's so easy to find the volume now. So let us just find out. Therefore, its volume will be equal to a cube, because volume of a cube formula is h cube. So a is now 16 into 16 into 16 centimeter cube. So let's write this one down. 16 into 16 multiply 6 is 36, 9, 6 1, 6 5 2, and then again multiply to 16. 36, 6 5 is 30, 33, 3 in hand, 6 to the 12, 15, 6 5 1, 6 9 10. I think this is 1 2 is 2, sorry. 1 2 is 2, so 2 4. So 4096 centimeter square. Now the choice answer that match that is found in, let us go to 4096 is found in B. Choice B, which is 4096 centimeter cube. Sorry, this is cube, okay? Sorry, volume. 3-dimensional always. So that is your answer. And A3, let us go to A3. Let me read the question for us. The lateral surface area of a cube is 256 meter square. Volume you have to find out. So again, cube. So let's just draw it quickly. Hollow or solid also, it's up to you. Okay, so here, the cube. The edge is not yet given. So let us just put again A. Let us write here, let A be the edge of the cube. Now, since it's given its lateral surface area is 256 meters square, I think. Yes. So with this information, let us try to do something. That is, the formula for lateral surface area means the 4 walls area. So we know that in the beginning of the chapter we did 4a square. Each means equal, and 256 meters square. So here 4, okay, a square, now we can find out, a square will be 256 divided by, this 4 will come down. 4 ones are 4, 6 are 24, 1 in hand, then becomes 16, 4 fours are 16. So a will be square root means square root over 64 meters square. So the 880 will come out single, meter will come out single. So value of the h is 8 meter. So we have to go and see volume of the cube. So its volume of the cube here will be a cube again. So now we got 8, so 8 into 8 into 8, and volume is 3-dimensional, meter cube. 8 is 64, and multiply to again 8, the third one. 32, 3 in hand, 8 6 are 48, 49 50 51, so 512. So 3 remainder here, okay? So 512 meter cube. So the answer that match this one is found in the choice A, which is 512 meter cube. So that is the volume. Okay. Finally, one more question. Now let's go to A4. A4 here. Let me read the question for us. The total number of planks of dimension 4 into 5 into 2. So let's just draw the first wooden plank is there. So it will be long, flat, and I think 4, 5. Okay, so it's a different kind of plank. 4. This plank is like this. 4. This is more. 5, and the thickness is small. So 4, let's draw it realistically, then it looks nice, right? So here 4, 5, and 2. So that means the question is saying that this one here 4 length, from here to here 5 more, so that's why I drew it taller, and this is 2 meter. So then there is a pit. Okay, so let's just write here dimensions of each plank, wooden plank, dimensions of each plank. Okay, so here small l equal to 4 meter. Let us say the length, in this case the length is shorter than the breadth. B is 5 meter, which is the breadth, BREADTH, and h is equal to 2 meter, which is the height. Or better let us put it as thickness, because it's so short that thickness would be a more appropriate word. Okay, so that is the one. Then question goes on to say this has to be stored in a pit 40 meter long, 12 meter wide, and 50 meters deep. So there is a pit here, underground pit of a cuboidal shape. So here the pit is, this is the pit, this is the plank. Okay, so here 40 into 12 into 50, so this is 40 meter long, 12 meter wide, and 15 meter deep. That's what the question is saying. Okay, yes, 15 or 12 meters wide and 50 meters deep, sorry, 50 meters deep. Okay, so 40, 12, and 50. So this is dimension, so we write here dimensions of the pit. Dimensions of the pit. Here capital L equal to 40 meter. This is the length of the pit. Capital B, let us say, is 12 meter. 12 meter, this is the width of the pit, WIDTH. And H is equal to 50 meter. Is the depth of the pit, DPTH. So with this, we have to find how many number of planks can go inside this pit. So let's just write that down. Therefore, required numbers of planks that can go inside this pit. Required number of planks will be equal to, simply given by the formula, volume of the big pit, volume of the pit divided by volume, okay, volume of each plank. That will give you the answer for number of planks that can go inside. So if volume of the pit is capital LBH, volume of the cuboid, small lbh for pit plank, sorry. Then here L capital 40, 12, and 50. 50, 40 into 12 into 50, and volume is 3 dimensional, so meter cube. Small l 4, 5, and 2, so 4 into 5 into 2, and meter cube again. So these 2 meter cube cancel. Maybe we can do 5 tens are 50. Okay, and then 4 threes are 12. Then here 2 20, and 2 threes are 6, and double 0. 600 number of planks can go inside, right? So that is how you can calculate. So now the answer that matches the 600 is going to your choices, and A is the answer. So these are the 4 questions that we have dealt with in this video. Okay, that is the end of this video. One more is there before we complete this chapter that will deal with the examples. Okay.